here we have been told that alpha hydrogens of esters, they have a pK of 25 and ketones have pK of 20. Now what we have observed is that there is a difference in the pK values of esters and pK values of ketones. So we have to find the reason for this difference. So now we have been mentioned that acidity of alpha hydrogens is being talked about. So I have made the molecular structure of a given type of methyl ester and a given type of methyl ketone. Now in these cases, whenever we talk about acidity, the central concept is that higher the acidity, lower is the pKa value, and acidity basically is developed when an hydrogen atom is going to be released in the form of an hydrogen ion, leaving behind the conjugate base or a carbon ion. Now the alpha hydrogen, one of the alpha hydrogens will be released in the form of hydrogen ion from this location, thus leading to the formation of a negative charge over here. Now this negative charge will enter into a resonance with the carbon oxygen double bond, and here also in the ester molecule the negative charge will enter into a resonance with the carbon oxygen double bond. Thus what we are able to observe is that the parts of the molecules which are located left of the curved line are going to be similar. Now any difference in the stability of the molecule, it will be based on the alkyl group located over here and the alkoxy group located over here. Now as we know, the alkyl group is always going to exercise a plus I effect, and the alkoxy group or OR group is going to exercise an R plus effect. Both I plus and R plus are electron donating effects, and we know this very well that higher the stability of the conjugate base, higher is the acidity, lower is the pKa. Now I already have a negative charge on a carbon ion, and when I have an electron donating effect, the stability of the carbon ion is going to decrease. And as we know, the AERHI rule, A stands for aromaticity, E stands for equivalent resonance, R stands for resonance effect, H stands for hyperconjugation, I stands for inductive effect. Aromaticity has the strongest influence on stability, and inductive effect has the lowest significance, lowest influence on stability. Thus, R plus effect is much more influential and much more stronger as compared to I plus effect, and both these effects are electron donating. Both are going to destabilize a carbon ion, but here R plus is stronger. Therefore, it is going to destabilize the carbon ion much more than the I plus effect. Thus, for ester, the carbon ion will be destabilized. Thus, the acidity will be much lower. Thus, the pK will be higher. Thus, I have observed that the alpha hydrogens of the esters have a higher pK value than alpha hydrogens of the ketones. This is a part of the question here. Thus, after reading the options carefully, what we will understand is that option C is the appropriate answer, that the electron donating effect of the alkoxy group in esters is going to destabilize the enolate or the carbon ion.